Open page number 154 or yes, open page number 155. Trigonometric ratios and their reciprocals with the help of unit circle. Unit circle mean whose radius is 1. Unit circle mean whose radius is 1. 1 centimeter or something. Let theta be the real number which represent the radian measure of an angle in standard position. Standard position means initial arm on x-axis and terminal arm in any quadrant, first, second, third or fourth. Let P, X, Y be any point. This is the point P on the unit circle lying on terminal side of theta as shown in the figure. We define sine of theta written as sine theta and cosine of theta as cos theta as sine theta equals to, we know that sine theta equals to perpendicular by hypotenuse, and in this case we take this theta, this is our perpendicular and this is our hypotenuse and this is our base. This is base, this is perpendicular and this is hypotenuse. Now we write EP by OP. This is E and this is P. EP by this line is EP and this is OP. The blue color or purple color is OP. EP equals to Y because it's unknown or height, and OP equals to 1 because I told you previous a unit circle mean whose radius is 1. So we can replace OP by 1 because OP is the radius of the circle and the length of circle is 1 centimeter or 1. It may be meter, centimeter, whatever. So sin theta equals to Y, and in similar way we write cos theta equals to X. So with the help of sin theta and cos theta we can find the remaining trigonometric ratios. Tan theta equals to, tan theta can be written as sin theta by cos of theta, and sin theta equals to Y and cos theta is equal to X. So, or sin tan theta can be written as P by B. Also we can say that tan theta is equal to P by B. And in previous page, on previous page, perpendicular is EP and base is OE. So tan theta equals to EP by OE and Y equals to Y by X. Tan theta is equal to Y by X. X is not equal to 0 because if X is equal to 0 then it's undefined or undeterminate form, undefined. Y equals to sin theta, X is equal to cos theta, so tan theta can be written as sin theta by cos theta. Cot theta is equal to X by Y, so cot theta can be written as cos by sin theta. These are important results which we deduct from here. And secant theta is equal to 1 by X, reciprocal of cos, and cosecant is reciprocal of sin. These are the 6 results which we use in next exercises. Example number 2, find the value of the trigonometric ratios at theta if point is on the terminal sides. Examples are exempted in short syllabus, so we skip this topic, and the next topic is the value of trigonometric ratios for 45, 30 and 60. These are the here explain how sin theta or sin 45 is equal to 1 by square root 2k. Read it carefully. We skip this topic because this we didn't need to solve or explain this topic here. Okay. Then sign of trigonometric ratios in different quadrant. This is important. In case of trigonometric ratios like sin theta, cos theta, tan theta is not in quadrantal angle, then theta will lie in a particular quadrant. Since r equals to square root x square, r equals to x square plus y square square root is always positive. The sign of ratios can be found if the quadrant of theta is known. If theta lies in first quadrant, then a point xy on its terminal side has x and y coordinate positive. I already explained this in class, so I repeat it again. Here, first quadrant, second quadrant, third quadrant, fourth quadrant. Here x is positive. On this line, x is positive. On this line, y is positive. Here, x is negative. Here, y is negative. If theta lies in first quadrant, then x positive, xy means positive. Both the sign of x and y is positive, and in second quadrant x is negative but y is positive. Y is positive. In third quadrant both are negative, and in fourth quadrant x is positive, y is negative. So a sin theta can be written as p by h or y by 1, or sin theta is equals to y. In first quadrant, I write it again. In first quadrant, sin is positive because x is positive. Sorry, y is positive. Here we look, y is positive. In second quadrant, sin theta, y is positive, so sin theta is positive. In third quadrant, sin theta is negative. In fourth quadrant, we check the sign of y. Y is negative, so it's negative. Sin is negative. If we check cos theta is b by h, and b equals to x and h is equals to 1, because we discussed sin theta, cos theta and tan theta in unit circle whose radius is 1 and hypotenuse equals to 1. So cos theta depends upon x, and now we check the sign of x. In first quadrant x is positive, so cos is positive. In second quadrant x is negative, so cos is negative. In third quadrant again x is negative. In fourth quadrant again cos is positive. So in first and fourth quadrant cos is positive. In second and third cos is negative. In similar way, if we check tan theta depend both on y and x. So if both the sign of y and x is positive, then tan is positive. If both the sign of y and x is negative, then tan is positive. In first and third quadrant, tan is positive, but remaining two quadrant, tan is negative. Reciprocal of sin is cosecant theta. So cosecant is positive, where sin is positive, and the reciprocal of cos theta is secant theta. Reciprocal of tan theta is cotangent theta. So where cos is positive, secant is positive. If tan is positive, then cot is positive. If tan is negative, then cot is negative. Using these results, we may write in first quadrant all trigonometric ratios are positive, all positive. In second quadrant sin is positive. In third quadrant tan is positive. In fourth quadrant cos is positive. If we take the first element of these trigonometric ratios, then ASTC, or we may remember this by a sentence: add sugar to coffee. Add sugar to coffee mean all positive in first quadrant. S for sine, T for tan, C for cos, A for all, S for sine theta, T for tan theta, and C for cos theta. First quadrant, second quadrant, sorry, this is first quadrant, second quadrant, third quadrant, and fourth quadrant according to the position of the words. Add sugar to coffee. This is what we have seen here, or this is add sugar to coffee. Add sugar to coffee. This is add sugar to coffee. Okay. Now we move on our exercise. Now we resolve our exercise on page number. This is our exercise on page number 162. These are according to short syllabus question. If you have any problem in this exercise, please ask me. Then I resolve that particular question, and then we go on 7.4. Yes, students. You have any problem in this exercise, please ask me. Question number 1 is MCQs, question number 2 is MCQs, 3 is MCQs, also 4, 5 MCQs, but in short syllabus there is no 4, 5 question. So these 3 are important questions, 7, 8, 9 and 10. Please, if you have any question, please ask me.
No question, sir.
No question in this exercise. Okay. Now I move on. Next exercise, which is related to trigonometric identities. Yes. Here, in this exercise, we have question number 8, 9, 11, 12, 13, 16, 17, 18, 21, 22, and 23. I start from question number 8, which is sin theta plus cos theta by cos theta equals to exercise number 7.4. Question number 8. What is question number 8? Question number 8 is sin theta plus cos theta. Sin theta plus cos theta divided by cos theta equals to 1 plus tan of theta. How can we solve this? We use the result, some specific result, that tan theta equals to sin theta by cos theta. We know that. So we take left hand side, we write sin theta plus cos theta by cos of theta. We may write it as sin theta by cos of theta plus cos of theta by cos of theta, using this result. If we have a plus b by c, we may write a by c plus b by c, using this result. Okay. Now cos theta can be cancelled with cos of theta, and we have left with sin by cos becomes tan of theta, using this result. And it becomes 1, and we rearrange it 1 plus tan of theta, which is right hand side. This is first question which I solved here. Now please tell me any other part or any other question from this exercise you feel difficult. Yes, my dear students. If you have any question, then ask me. I will resolve that particular part. We have left 20 minutes. Yes?
सर 23 या 24 जो अंडर रूट में है उनमें से कोई एक करा दे.
Okay, good. Ismail 23 या 24 में से कोई एक करा दो। 23 काइंडली बोल दीजिएगा 1 प्लस कॉस थीटा बाय स्क्वायर रूट 1 प्लस कॉस थीटा बाय 1
1
माइनस
minus
कॉस ऑफ
cos theta.
इक्वल्स टू
Sin theta by 1 minus cos theta.
sin theta by 1 minus cos of
Cos theta.
theta. We take left hand side, thank you beta, and resolve this. 1 plus cos of theta by 1 minus cos of theta. We take help from right hand side. In denominator we need 1 minus cos of theta. So here if we multiply this by 1 minus cos of theta and divide by 1 minus cos of theta, we get the perfect square of 1 minus cos of theta whole square, which is our required on right hand side, because when we have a perfect square inside a square root, that term comes outside exactly the same. And in above we have 1 plus cos theta multiplied by 1 plus cos of theta into 1 minus cos of theta, it becomes 1 minus cos square of theta. And we know that by identities 1 minus cos square theta equals to sin square of theta. So we may write this as 1 minus cos square of theta square root 1 minus cos square becomes sin square of theta, and in denominator we have 1 minus cos theta whole square. Now we can take square root separately using the result which we have studied in second chapter of 9th. If we have square root a b, we may write square root a by square root b. Using this result, we have sin square theta square root and 1 minus cos theta whole square root. This square cancel with square root, this square cancel with square root, and we have left with sin theta by 1 minus cos of theta. Is it clear, Ismail?
Yes, sir.
Ismail. Okay. Any other student? If he face difficulty, please ask me. Otherwise, we go on 7.5 exercise. And then we have left only. Clear? Sorry? Any other question?
No, sir, no
Okay.
other question.
Good.